Hi everyone! In this video, we will calculate compound interest. A company's investment is growing at 5% compounded quarterly. Calculate the doubling time of the investment in years, round to the nearest hundredth. To do this, we need to have our compound interest formula. This is the amount final in terms of time equals the principal times 1 plus the rate divided by the number of times compounded in a year raised to the number of times compounded in a year times time measured in years. We have a few of these things and we can put those into our equation. We were given 5% as our interest rate or compounding rate, and to calculate this, we need to change it to the decimal. Decimal is here. To change it, we need to move the decimal place 2 place values to the left, making this 0.05. Compounding quarterly, this means 4 times a year, so n equals 4. Now we are asked to calculate doubling time of the investment. This means that the final amount is twice the original amount. This means if my principal is the initial amount or amount at time 0 is represented by a sub 0 or a naught, then our amount final or a sub t will be twice that starting amount, a sub 0 or a at time 0. Now we can substitute everything we have into our equation. We end up with 2 a sub 0 equals the initial amount, a sub 0, times 1 plus the rate changed to a decimal is 0.05 divided by n is 4 times a year because it was quarterly, raised to the 4 times per year times the number of years, and that's what we're looking for, so we'll leave it as t. Now we need to solve for t, and let's do that by first dividing both sides by a sub naught or a at time 0, which we'll see cancels out on both sides, which means that we're looking for a doubling time with just 1 plus 0.05 over 4 raised to the 4t. To stay as accurate as possible, we're not going to do 0.05 divided by 4 and add to 1 until the very final calculation. So we're going to keep that all grouped together. To solve an equation where the variable is in the exponent, we need to bring it down, and we have a way we can do that by using logarithms. And my favorite is the natural log because it is already built in with the base, and it's faster to write ln instead of log base 10 or any other log. So we're going to use the ln and take the ln of both sides. If we take the ln of both sides, then it keeps the equal sign balanced. Now we can use our rules of logarithm, and the power rule brings the exponent down in front. So we end up with ln of 2 equals 4 times t times the ln of 1 plus 0.05 over 4. Now that our variable is out of the exponent, we can continue solving for the variable by isolating it. And that means that in this case, we need to do the opposite operation. Because it's being multiplied to the 4 and the ln, we'll divide both sides by 4, ln of 1 plus 0.05 over 4 on both sides. On the right-hand side, it will cancel out. And so we're left with t equals the ln of 2 divided by 4 times the ln of 1 plus 0.05 over 4. Now to type this into our calculator, in a graphing calculator, we'll type in ln, and this on the 84 is the second button on the left above the on. It will open a parenthesis for us. We'll type in a 2 and close the parenthesis, and then divide by, open a parenthesis so that we get everything on the bottom in the denominator. So we have a set of parentheses around everything down there, and we'll have 4 times ln. You don't have to put a multiplication sign unless you want to, because the calculator will automatically assume that you're multiplying 4 times the ln. And then it'll open another set of parentheses for us, and we'll type in 1 plus 0.05 divided by 4, and close the set of parentheses for the ln. Then we'll need to close the second set of parentheses for everything to stay in the denominator. Then we'll press enter, and this gives us 13.9494. We were asked to round to the nearest hundredth. The hundredths place value is the second place value after the decimal. The 9 is greater than 5, so it'll raise the 4 to a 5, making this 13.95, and we were asked the time, so we need to label this as years. We've now found that for this company, the doubling time for its investment is almost 14 years. And now we're all done.